This is my energy wedge along with some visuals. The cost categories are low, moderate, and high. The first wedge is nuclear energy. Nuclear electricity produces no carbon dioxide. Adding nuclear plants that triple the current nuclear capacity is equal to one wedge. This can be done at a moderate cost, but there are challenges such as the disposal of nuclear waste and opposition from the public due to safety concerns and radiation leaks. Increased amounts of plutonium from the nuclear fission means more materials available for the production of nuclear weapons. The second wedge is a fossil fuel-based strategy. Carbon capture storage recovers 90% of the carbon dioxide produced by fossil fuel power plants and is injected and stored underground. One wedge would require 3,500 times the capacity of just one of the current projects. This can be done at a moderate cost. The challenge is to make sure that the carbon dioxide remains safely in storage sites for thousands of years. There is the threat of fractures forming and causing leakage of carbon dioxide. Leakage would contaminate the ground and seep into our well water, causing illness, disease, and possibly death. The third wedge is efficiency and conservation. Efficiency building can be achieved by using the best available technology in existing and new buildings. Increasing insulation in walls and roofs using fluorescent instead of incandescent bulbs, buying energy efficient appliances, and using insulated storm windows could possibly cut emissions in half. This would account for one wedge and can be done at a low cost. One challenge is simply the extra cost. Another is that not everyone is financially able or even willing to take the necessary steps. The fourth wedge is the fossil fuel-based strategy of fuel switching electricity. Natural gas plants that produce electricity emit about half as much carbon dioxide than coal electric plants. Coal-fired plants cannot easily switch fuels. New plants will have to be built, which take a lot of time and money. The cost would be in the low category. Natural gas supply is limited because it's not a renewable resource. Also, there would still be some carbon dioxide emissions. The fifth wedge is efficiency and conservation. Transportation efficiency can be achieved by increasing automobile fuel efficiency in cars from 30 miles per gallon to 60 miles per gallon. The cost would be in the low category. Part of this would come from hybrid and diesel engine technologies. Challenges would be having to drive smaller cars with less powerful engines. There is much opposition to this technology by big oil, coal, and gas companies. Reducing the need of fossil fuels takes big money out of their pockets. Another challenge is getting people to change their buying habits. Not everyone is sensitive to environmental needs. The sixth wedge is renewables and biostorage. Using wind to generate electricity is growing every year, but to replace one wedge, we would have to increase the current capacity by 10 times. Using wind is moderately expensive and there are challenges. Not everyone is eager to have windmills on or around their property. They cause damage to wildlife like birds and bats that fly in their path. Also, wind can be unreliable because the wind is not always blowing. The seventh wedge is efficiency and conservation. Increasing the efficiency of electricity production can increase the efficiency of power generation from 40% to 60% by using better turbines and high-temperature fuel cells. Coal-burning power plants produce about 1/4 of the world's carbon emissions. Doubled efficiency would equal one wedge. There would be increased plant costs up front, but the cost would be in the low category. Even with the reduction, there is still the challenge of carbon dioxide emissions. The last wedge is renewables and biostorage. Biofuels are already being made from plants, and they do not produce harmful emissions of carbon dioxide from vehicles. To create one wedge, biofuel production would have to increase 12 times what it currently is. The cost in doing this is moderate. The land needed to grow crops for the demand would require 1/6 of the world's cropland. Another dilemma is using farmland for biofuels production instead of food production. Indirect carbon dioxide emissions are caused by land use change, like cutting down rainforests to grow food crops. Also, machinery causes emissions when planting and harvesting crops for biofuels.